We've been finding derivatives of trig functions combined with the product and quotient rule for a few problem sets now, but I want to do just a couple more. And these are tough, so I want to focus on them a little bit. In fact, I'm going to do the one on bottom first because I think it's the hardest. And if I mess up, I won't mess up my recording time for nearly as long. Of course, that's very important. X squared sine x tangent x. I want to take note that I posted these rules up here since we've derived them in previous problem sets, and I went through the lecture series on how to find them yourself. I think that that's covered. So we have the derivative of secant and tangent that I'm going to call known information, which is going to come in handy here, of course. So everything is multiplied, means if I want to find the derivative of f of x, I'm going to use a u and v and a product rule, which says u prime v plus v prime u. This isn't a u, this is a v. Moving too fast. Okay, so for this here, we need u, which is x squared sine x, and then our v is tangent x. V prime we know is secant squared, and u prime is going to require another product rule. And we'll make a new u, which is x squared. We'll make a new v, which is sine of x. We'll make a u prime, which is 2x, and a v prime, which is cosine of x. So u prime v will be 2x sine of x plus v prime cosine of x times x squared. That will be this u prime here. So to do our full product rule, I guess we can come over on this side a little bit. Well, let's just come down a little ways, might be better. Is u prime v plus v prime u. We've done it a lot of times now. It's just uglier this time. 2x sine x plus x squared cosine x. That's our u prime times tangent of x plus our v prime secant squared and u. So it'd be x squared sine x. That looks ugly, but it actually wasn't a lot of algebra. I don't know how cleanly you could separate all of this. I guess you could take an x out of there, and maybe if you play with the sines and cosines, you'll have some fun with it. But this is a correct answer, and we'll use that one going forward. Let's look at the next question. F of x equals cosine x. I hope you guys are learning something from this. 1 minus sine of x. This is a quotient rule problem. There's one on top and one on bottom. So it's a quotient rule. The quotient rule says u prime v minus v prime u over v squared. What's our u? That's the numerator, that's cosine. What's our v? It's the denominator, 1 minus sine of x. This shouldn't be that bad. U prime will be negative sine of x. V prime will be, that's nothing, so negative sine of x. His derivative is negative cosine of x. Okay, we have what we need. We have a negative sine x. That's our u prime, our v, 1 minus sine of x, minus v prime, negative cosine of x. There's a lot of minus signs in here, times cosine of x. And it's all going to be over 1 minus sine of x. The whole denominator squared. Be very careful about that. So let's see what we can do here. We distribute this and we get a negative sine of x plus sine of x squared plus cosine of x squared over 1 minus sine of x squared. And of course, sine of x squared plus cosine of x squared is 1. So this becomes a 1. It becomes a 1 minus sine x, which is what's in the bottom. So this actually cancels off, and we're going to get 1 over 1 minus sine of x. And that is the correct answer. So if you're able to arrive at this, you are good to go on the product rule and on playing with trig functions. See that you don't go through the problem set and figure some of them out.